Pistons are key to the internal combustion process that drives engines. A piston is a plug that slides up and down inside each cylinder, compressing gas and air ignited by a spark plug. The resulting energy turns the crankshaft and drives the engine. This company makes 9,000 different types of pistons. For everything from dirt bikes to car engines. A piston starts out as a 3-meter-long aluminium rod. Aluminium is ideal because it's a lightweight, rust-resistant and easy-to-cut metal. A rotary saw slices the rod into slugs, the length of which can be changed by adjusting the feeder machine to push the rod at different intervals. This piston model requires 7-centimeter slugs. The factory recycles excess aluminium shavings. The punch press and die are preheated to 426 degrees Celsius, the temperature required to forge the slugs. The slugs are brought to the same temperature in an oven. The punch applies 2,000 tons of pressure to form it into the initial shape of the piston. About 1 in 10 forgings are dunked in water to check for defects. To make forging easier, they pre-lubricate the slugs before heating them. That's why the slug flames up when struck by the press. It only takes 2 seconds for the press to do its job. But the forgings are so hot, they need at least an hour to cool before the next step. Workers heat the forgings twice more. The first time at a very high heat to strengthen the metal. The second time at a lower heat to stabilize it. Now, they insert each slug in a lathe to give the forging the correct shape for machines that handle it later. These small holes allow oil to flow through to lubricate the piston when it's in use. Another lathe reduces the diameter by 3 millimeters. The same machine then cuts 3 grooves, 2 for compression rings and another for an oil control ring. These rings help the piston glide and enable it to provide an airtight seal. This hole is for the wrist pin, which will attach the piston to the connecting rod. A milling machine then shaves off up to 2 centimeters of metal from 2 sides of the piston to reduce the overall weight. The white liquid is lubricant to cool the area during cutting. Another milling machine cuts away part of what they call the dome. This way, it'll clear other parts when moving inside the cylinder. The piston must be just the right shape and size. Some of them move up and down as much as 6,000 times per minute when the engine is running. Next, a lathe shaves a hair width more of the metal from the outside. This cut enables the piston to expand slightly when the heat builds up inside the cylinder. An automated drill makes 2 intersecting oil drain holes to enhance lubrication of the wrist pin. Another machine now engraves model and production data. Here, a worker removes sharp edges created during previous operations. He then uses a belt sander to further smooth out the surface. Sharp edges could damage the cylinder walls. This cutting machine shaves off a bit of metal inside the pinhole, so the wrist pin will fit snugly inside. Once the cutting's complete, high-pressure jets spray the pistons with hot deionized water. This cleaning removes all traces of lubricant and oil. And after a blow-dry with an air gun, these pistons are ready to go through their ups and downs.